হ্যালো, এখন আমরা ওপেন সেটের চ্যাপ্টারে দুটো অঙ্ক নিয়ে আমরা আলোচনা করব। So the first problem is, it is given that S is the set semi-open interval and T is the set containing the elements of the type 1 by n, where n varies over the set of all natural numbers. So we have to check whether S minus T is an open set or not. And the question number 2 is here S consisting all those real numbers for which sign x does not vanish. So here the same problem whether S is an open set or not. So let us check. So first of all, we sketch the real line, and first of all we sketch this set a semi-open interval. Suppose this one is 0 and 1 is here, so and 0 is open and 1 is closed. Now we consider the elements of the T, 1 by n. So if we n equal to 1, for n equal to 1 we get the first element as 1, so this one. And for n equal to 2 we get half. For n equal to 3 we get 1 upon 3. For 4 we get 1 upon 4, etc. 1 by 5, 1 by 6, this. Now we have to find S minus T. So this set will be obtained by deleting all those elements of T which are also in S. So we will delete the elements of T which are 1, half, 1 upon 3, 1 upon 4, 1 upon 5, 1 upon 6, etc. So if we delete all those elements from the set S, that means semi-open interval, so we will get this one from half, from the right of half to the left of 1, so it is an open interval. So this set is half, 1 open interval. Next, this open interval we will get, so its union is 1 and 3, 1 by 3 and 1 by 2. And similarly we will get the third set as open interval 1 by 4, 1 by 3, etc. Similarly, if we proceed, we will get 1 by n plus 1, 1 by n. So this is the nth term. So if we put n equal to 1, we get half 1, the first one. If we put n equal to 2, then we get 1 by 3, 1 by half, this one we get. So it is the nth term. So dot. So this will give S minus T. We have already deleted the elements 1, half, 1 by 3, 1 by 4, etc. So this one. Now we see that this is an open interval. Open interval. Each of these is an open interval. And we know that every open interval is an open set. Every open interval is an open set. And also we know that arbitrary union of open sets is also an open set. Also, arbitrary union of open sets is also an open set. So the conclusion is that S minus T is an open set. So the first one is solved. So S minus T is an open set. Now we go to the second question. Here S is a set consisting of all those real numbers for which sign x does not vanish. So to do this, let us start with sin x as 0. First of all, we find all those x for which sin x vanishes. So sin x is equal to 0 from higher secondary. We know that sin x is 0 if and only if x equal to n pi, where n belongs to the set of all integers. So here too we sketch the line and see what we observe. So n belongs to z, the set of all integers. So if we take n equal to 0, so it will be 0. If we take n equal to 1, then equal to pi. For n equal to 2, you get 2 pi, etc. For n equal to minus 1, you will get minus 1 pi. So minus pi, similarly minus 2 pi, etc. Now S is the set consisting of all those elements in R for which sin x does not vanish. But we have taken here sin x vanishes for all those elements. So we have to delete all those elements from the set S. So S is the set you get from the real line. We delete these elements. So minus 2 pi, minus pi, 0, pi, 2 pi, etc. Or we write n pi such that n belongs to z. Now from the figure we see that this set can be written as, if you delete all those terms, so we'll get in between this set. So this set will be pi, 2 pi. So this one 0 pi, this one minus pi 0, this one minus 2 pi pi, etc. So this is nothing but S. So what we see is that this is an open interval. All these are open intervals, and in the first problem we have seen that arbitrary union of open sets is also an open set. The same logic we apply over here. Here we see that S is the union of an arbitrary family of open sets, and we know that arbitrary union of open sets is also an open set. So here S becomes an open set. S is an open set since each set on the right hand side of 1 is an open set, and S is a union of arbitrary number of open sets. So S is an open